It is June 1944, somewhere in the cold grey waters of the North Atlantic. A thin mist clings to the surface, drifting across the bow of a lone American escort destroyer pushing through heavy swells. Its crew has been chasing a sound, faint, rhythmic, unnatural. Deep below them, an enemy U-boat moves in silence, believing the ocean is still on its side. Inside the ship's dimly lit combat information center, a young sonar operator leans closer to his headphones. A sharp ping returns, then another. The pattern is unmistakable. A new American device, compact, overlooked, almost unknown outside naval circles, has just given the U.S. Navy an advantage that commanders in 1942 could only dream of. Moments later, depth charges roll off the stern. The ocean erupts. A plume of water rises into the air. The conv, carrying weapons, fuel, and food across the Atlantic, continues on, safe, because of an invention few modern viewers have ever heard of. And this was only one of many. Across labs, workshops, factories, and forgotten corners of America, innovations were quietly reshaping the war long before victory was visible. In the final months of the 1930s, the world was already cracking under the weight of accelerating conflict. Europe had fallen into open war. Asia had been burning for years. Yet across the Atlantic, the United States still stood officially apart, its military small, its technology scattered across competing agencies, its industry powerful but unfocused. American leaders understood that another global conflict was rising, but few could predict just how rapidly the nation would have to reshape itself to survive it. By 1939, Germany's blitzkrieg had demonstrated a new kind of warfare, fast, coordinated, driven by radio communication, mechanized maneuver, and ruthless precision. Britain struggled to hold the line. France collapsed in less than 6 weeks. In the Pacific, Japan pressed deeper into China and looked towards Southeast Asia and the Pacific Islands. The oceans began to look increasingly dangerous, and air power was advancing faster than most nations could adapt. For the United States, the quiet realization was this: traditional methods, traditional equipment, and traditional thinking would not be enough. If America entered the war, and many believed it eventually would, the nation would need tools that did not yet exist. Yet in 1940, American troops were still training with weapons from the previous war. Aircraft lacked advanced navigation gear, radios were inconsistent and vulnerable, anti-submarine tactics were primitive, and logistics, the fuel of modern warfare, was stretched thin even in peacetime. The US wasn't weak, but it wasn't modern, not yet. But beneath the surface, something extraordinary was beginning to take shape. In university basements, engineers were experimenting with crude prototypes of devices that would later guide planes through storm-filled nights. In small government research offices, chemists were discovering new materials that could resist heat, stress, and corrosion. At naval yards and private shipyards, technicians quietly refined the first practical sonar sets, machines that would turn the Atlantic from a hunting ground into a battlefield where submarines were no longer invisible. By 1941, even before Pearl Harbor, the United States was accelerating. The National Defense Research Committee and soon the Office of Scientific Research and Development were pulling professors, industrialists, physicists, and engineers into a coordinated effort unlike anything America had attempted before. It was the beginning of an immense national fusion of science, industry, and military strategy. The German U-boat threat provided one of the earliest and most alarming warnings. In the first months of the Battle of the Atlantic, convoys suffered heavy losses. Allied ships lacked advanced sonar, radar, reliable depth-charge fuses, and coordinated air-sea communication. Every shipment of steel, oil, or ammunition lost at sea slowed the Allied war effort. Every sinking tightened the noose around Britain. And every sinking sent a signal to American scientists. Innovation was no longer optional. New forms of detection, new explosives, new communication systems, new navigation tools, everything needed improvement. The war was not simply being fought with tanks and rifles. It was being shaped by the quiet, unseen labor of researchers who often never stepped onto a battlefield. Then, on December 7, 1941, when Japanese aircraft struck Pearl Harbor, the United States was thrown into full-scale war. What had been urgent suddenly became existential. America now faced an enemy across two vast oceans, each demanding different strategies, different machines, different technologies. The Pacific required long-range endurance, amphibious innovation, and communications that could operate across thousands of miles. The European theater required precision navigation, radar-guided bombing, and air defense systems capable of countering German night fighters. Both theaters needed manufacturing speed the world had never seen. Factories that once produced cars shifted to building aircraft, radios, and advanced electronics. Laboratories expanded. Naval shipyards ran day and night. America was becoming an industrial and technological engine, and inventions were appearing at a pace that surprised even its military commanders. Some, like the proximity fuse, would later be celebrated. Others, like synthetic rubber, the first practical combat radar altimeters, improved depth charge pistols, and new amphibious landing devices, remained overshadowed by larger, more dramatic wartime breakthroughs. Yet these forgotten innovations filled the silent gaps. They made long missions possible. They made convoys survivable. They turned night into an advantage instead of a weakness. They allowed the United States to project its power across oceans far larger than any army had ever attempted to cross. As pressure mounted in both hemispheres, America's scientific momentum grew, creating a foundation that would soon reshape entire campaigns. And the problems confronting the nation in those early years, tactical failures, logistical nightmares, and technological shortcomings, would soon point directly to the inventions that changed the war forever. By the start of 1942, the United States confronted a battlefield reality unlike anything its planners had imagined. The shock of Pearl Harbor had rippled through every branch of the military, revealing weaknesses that could no longer be ignored. American forces were brave, determined, and numerous, but they were also inexperienced, unevenly equipped, and logistically strained. Early battles exposed problems not of courage, but of technology. Nowhere was this more visible than in the Pacific. The distances were staggering. Islands were scattered across thousands of miles of open ocean. Aircraft had to fly farther than ever before. Ships needed to operate for weeks without resupply. And amphibious assaults, an almost niche operation before the war, became central to the entire Allied strategy. The Marines learned quickly that traditional landing craft struggled on coral reefs. Tanks bogged down, soldiers waded through chest-high water under fire, and supplies arrived too slowly to sustain momentum. Engineers back in the United States took note, developing new types of amphibious vehicles, new landing craft designs, and improved waterproofing and radio gear to coordinate the chaos of beach assaults. Many of these innovations would remain overshadowed by more iconic wartime machines, yet they were crucial in island after island. In the air, American pilots faced similar challenges. Flying over the Pacific meant dealing with storms, darkness, and long stretches of ocean without landmarks. Early navigation systems were unreliable. Radios drifted off frequency. Bombers sometimes missed targets by miles. To address these problems, researchers worked relentlessly on lightweight radar sets, improved gyrocompasses, new radio beacons, and devices like radar altimeters that allowed aircraft to fly low even through thick cloud cover. These were not glamorous inventions, but they saved lives and missions every day. Meanwhile, across the Atlantic, the Battle of the Atlantic intensified. German U-boats roamed in coordinated wolf packs, sinking Allied shipping faster than shipyards could replace lost tonnage. Merchant sailors began referring to the ocean as a graveyard. The Allies needed not just more ships, but smarter ships. American scientists responded with a wave of innovations. Advanced sonar systems that penetrated deeper and more clearly. Improved depth charge pistols that detonated more reliably at set depths. high-frequency direction finding (HFDUF) units that pinpointed U-boat radio transmissions, early long-range airborne radar that finally made night and fog unsafe for German submarines. These technologies were modest in appearance: small metal boxes, coils of wiring, new switches and dials, but on the sea they were transformative. Convoys that had once been helpless now fought back with precision. At the same time, the United States faced a material crisis. Japan's early advances cut off the world's supply of natural rubber, essential for tires, gaskets, seals, wiring, and countless other components. Without rubber, trucks would sit idle, aircraft would be grounded, and factories would slow to a halt. In response, American chemists pursued synthetic rubber, creating new materials that allowed production to accelerate rather than collapse. It was one of the largest industrial miracles of the war, rarely mentioned, but vital. On land, battlefield communication remained a constant concern. Infantry radios were heavy, fragile, and had limited range. Armored units struggled to maintain contact during rapid movement. Field commanders relied on wire lines that could be cut by shells or accidentally severed by their own vehicles. The push for compact, rugged communication gear drove innovations like the SCR-300 walkie-talkie, a device whose impact on coordination, speed, and survivability is often forgotten today. These were not heroic inventions in the traditional sense. They weren't the massive bombers, the dramatic carrier fleets, or the tanks featured in war posters. They were subtle solutions to massive problems, and because they solved those problems quietly, steadily, and behind the scenes, they faded from popular memory as the decades passed. But in the moment, their impact was unmistakable. They closed gaps the enemy had once exploited. They allowed American forces to fight with growing confidence. They transformed chaos into something structured, predictable, manageable. Across the country, the collaboration between scientists, industry, and the military intensified. Ideas moved faster, prototypes became equipment, failures became improvements. The US was learning at extraordinary speed. And as each small innovation entered the battlefield, commanders began to realize a truth that would shape the entire war. The path to victory would not be defined only by the famous weapons, but by the forgotten ones, the inventions that quietly changed how the war was fought. These inventions would soon be viewed through many different lenses: human, tactical, technological, and even by the enemies who felt their effects most sharply. And to understand their full impact, we must examine the angles through which they reshaped the war. War is never shaped by a single invention, a single breakthrough, or a single moment. It is shaped by layers: human, tactical, technological, psychological, and the forgotten American innovations that helped turn World War II were no exception. Their importance becomes clear only when viewed through multiple angles, each revealing how these subtle creations altered the battlefield in ways most modern audiences have never been taught to see. Below are the first set of angles, 3 perspectives that illuminate how these inventions reshaped the war not through spectacle, but through quiet, indispensable influence. Before the inventions reached the battlefield, they lived in the minds and hands of ordinary Americans, students, immigrants, engineers, machinists, and scientists who rarely imagined their work would change the course of the most destructive war in history. Many were young, some had never traveled beyond their hometowns. Others had escaped totalitarian Europe and brought with them hardened knowledge of the technology Germany had been developing for years. Inside the halls of MIT, Bell Labs, the University of Chicago, Caltech, and dozens of other institutions, teams worked with a pressure they had never known. The stakes were immediate. Every improvement in radar meant another bomber might return home. Every refinement in sonar meant dozens of sailors might survive the night. Every ounce of synthetic rubber produced meant a convoy might reach Britain, a tank might reach the front, a bomber might fly another mission. Researchers often slept in their labs. Factory workers labored through 16-hour shifts. Housewives learned precision assembly and winding techniques for delicate electronics. Draft exemptions were sometimes granted not because men avoided danger, but because their hands were too valuable in shaping machines the front lines desperately needed. These were not glamorous roles, but they were essential. And through the human stories behind the inventions, we see the quiet, relentless determination that powered America's wartime transformation. Every battlefield in World War II revealed weaknesses, gaps in communication, failures in detection, vulnerabilities in navigation, and American inventions emerged specifically to close these gaps. Take the Atlantic. Before advanced sonar and improved depth charge pistols, escort ships often attacked U-boats blindly. Charges detonated too shallow or too deep. Convoys zigzagged aimlessly. But with new American detection gear, escorts could track submarines with increasing precision. Wolf packs that once terrorized the shipping lanes suddenly found themselves hunted. In the air, tactical innovation meant survival. Radar altimeters allowed bombers to fly low over cloud-covered terrain without crashing. Lightweight navigation beacons allowed fighters and attack aircraft to find their carriers in darkness or storm. Early microwave radar sets installed in night fighters transformed them into lethal predators, turning German night skis into hazardous hunting grounds for the Luftwaffe. On land, improved communication gear changed the rhythm of battle. The SCR-300 radio, although bulky by modern standards, allowed infantry squads to maintain contact even in dense forests, chaotic villages, or fast-moving engagements. Commanders could react quickly, redirect fire, call for support, or withdraw before being overwhelmed. To the enemy, these tactical shifts felt sudden. They saw American units coordinating faster, attacking more precisely, and navigating environments that had previously favored defenders. What looked like luck or numerical advantage was often the product of quiet innovations created thousands of miles from the front. Some inventions changed the war not by dramatic appearance, but by fundamental capability. Synthetic rubber allowed the United States to build millions of tires, seals, gaskets, and cables that would otherwise have been impossible after Japanese forces cut off natural rubber supplies. Without it, the vast American vehicle fleet, trucks, bombers, tanks, jeeps, would have stalled before campaigns even began. The proximity fuse, a compact radio device inserted into artillery shells, transformed anti-aircraft warfare. Instead of relying on imperfect timing, these shells exploded when near an aircraft, drastically increasing the odds of hitting fast-moving targets like V-1 rockets or dive bombers. It was not a flashy invention. It was a small circuit, refined endlessly until it was rugged, reliable, and producible on a massive scale. Yet its effect on battlefield lethality was extraordinary. Sonar and radar miniaturization were equally transformative. Early detection instruments were large, fragile, and unreliable. American workshops found ways to shrink components, protect them from vibration, and mount them on smaller ships and aircraft. Suddenly, technologies once limited to specialized platforms became tools available across entire fleets and air groups. These inventions did not dominate headlines. They did not carry heroic names, but their impact was undeniable. They shifted the balance of technology toward a nation that was learning to fight a war driven increasingly by information, detection, and precision. The forgotten American inventions of World War II can be understood more fully only when we see how the enemy reacted to them, how they reshaped logistics, and how they altered the moral and psychological dimensions of the conflict. These angles reveal the deeper, often hidden influence that small devices and overlooked technologies exerted on the war's outcome. Below are the next three angles, each uncovering another layer of impact. German and Japanese commanders did not immediately understand why certain battles began slipping out of their control. At first, they believed it was simply growing American production, more tanks, more ships, more bombers, more men. But quantity alone did not explain the sudden shifts. German U-boat captains noticed something unsettling by late 1942. Convoys were finding them faster. Escorts attacked with accuracy instead of guesswork. Night operations, once the U-boat's refuge, became deadly. Messages sent over radio waves were intercepted quickly, revealing wolf-pack positions. To many German officers, it felt as if the ocean itself had turned against them. In the air, Luftwaffe night fighter pilots encountered a similar problem. American and British bombers were harder to ambush. They flew with new altimeters, new radar beacons, new countermeasures. Ground controllers could not easily disrupt their formations. Japanese naval aviators faced the same confusion in the Pacific when American carriers recovered planes in pitch-black conditions using technologies they could not yet replicate. Axis scientists were not incompetent. Some were among the most advanced in the world. But their research was hampered by limited industrial capacity, internal competition, and strategic overreach. They could not match the rapid, broad-spectrum innovation the United States generated with its vast scientific network. In enemy reports and diaries recovered after the war, a recurring sentiment appears. The Americans are learning too quickly. And behind that acceleration were the forgotten inventions that quietly altered the tempo of war. Every soldier, every aircraft, every ship depended on a single backbone, logistics. And logistics depended on countless small technologies that rarely receive recognition. Consider fuel. A modern mechanized army consumes it relentlessly. Trucks need it. Tanks devour it. Aircraft burn it by the ton. American engineers developed advanced fuel storage systems, flexible rubber hoses, new pump designs, and efficient supply connectors that allowed fuel to be transferred rapidly even in harsh environments. Without these improvements, the mobility of American forces would have collapsed. Consider tires. Without synthetic rubber, the U.S. Army would have suffered a catastrophic shortage by 1943. The entire transportation system, from jeeps to bomb trailers to supply convoys, required millions of tires. Synthetic rubber was not glamorous, but it kept the Allied war machine moving. Consider field packaging. American rations, often ignored in discussions of innovation, used new sealing techniques, lightweight cans, moisture-resistant liners, and durable crates that allowed food to last longer in tropical climates. A rifle company that remained fed during a jungle campaign owed as much to packaging engineers as to the quartermasters delivering the crates. Even ammunition benefited. The proximity fuse, once installed in artillery shells, required new shock-resistant packaging, new temperature-controlled storage solutions, and new transport protocols to keep the delicate electronics intact. Logistics teams adapted quickly, ensuring frontline units always received reliable stock. These logistical innovations formed an invisible web supporting every advance, every landing, every bombing run, every conv that made it safely across the sea. War is not only physical, it is profoundly psychological, and the forgotten inventions of World War II changed how American troops felt about their odds of survival. A sonar operator who trusted his equipment searched the ocean with confidence instead of fear. A bomber crew with a radar altimeter felt less terror flying through cloud-shrouded night. An infantry squad with reliable radios entered combat knowing they would not be isolated. A destroyer captain who understood his depth charges were now accurate down to meters attacked with determination rather than hesitation. These small boosts in morale mattered. They multiplied. They spread through units like fuel-feeding momentum. Even civilians felt this shift. America's home front gained confidence as newspapers highlighted industrial achievements, not just the number of tanks built, but the breakthroughs in materials, communication, and electronics. The nation began to believe not only that it could fight the war, but that it could fight it smartly, with tools that leveled the battlefield against enemies who had been preparing for a decade. Meanwhile, on the Axis side, the psychological effects cut the opposite direction. U-boat crews wrote of a creeping sense of doom as Allied detection became ever more relentless. Luftwaffe night fighters reported frustration and uncertainty as new American systems reduced their once formidable kill rates. Japanese commanders feared the growing reliability of American naval aviation, which seemed able to function in weather conditions that grounded their own forces. This invisible moral shift, rooted in forgotten inventions, became one of the most decisive factors of the war. But the true test of American innovation didn't happen in laboratories. It happened in the mud, heat, and terror of real battlefields. After the chaos of Belleau Wood and the harsh lessons of early Pacific engagements, U.S. commanders knew one thing. A weapon wasn't powerful unless a Marine could trust it when everything else fell apart. And that trust would soon be shaped in one of the most unforgiving places on Earth. The island breathes humidity like a furnace, fog clings to the trees, every shadow feels alive. A Marine squad moves cautiously along a narrow jungle trail, their boots sinking into black, waterlogged soil. At the front, a Marine with a Winchester Model 1897 trench gun. This isn't a battlefield of tanks and long-range rifles. This is point-blank war, where a single second decides who lives and who never sees home again. In the Pacific, enemies weren't seen at 200 yards. They appeared at 2 yards, sometimes less, exploding out of foliage, tunnels, and tree lines with terrifying speed. Japanese soldiers were masters of camouflage and close-quarters ambushes. And that made the shotgun, a weapon many nations saw as primitive, suddenly become one of America's deadliest advantages. The ambush. Leaves rustle, a Marine freezes. A Japanese soldier lunges from the greenery with a bayonet. There's no time to shoulder a rifle. Boom! The shotgun roars, a thunderclap swallowed instantly by the jungle. The ambush collapses before it even begins. Marines regroup, breathing heavily. They don't celebrate. They don't cheer. They simply look at the shotgun and understand why Germany once tried to have this inhumane weapon banned. Every major army in World War II underestimated the shotgun, except the US Marines. The Japanese feared it. The Germans protested it. And the Americans perfected it. But it wasn't just the weapon itself. It was the doctrine behind it. The US didn't only give Marines shotguns. They built entire tactics around them. Jungle pointman roles, trench clearing, bunker assaults, night patrol defense, ambush counterstrikes. Where other nations relied on bayonets and grenades, America relied on something far more devastating. A single blast delivering the power of dozens of projectiles in the blink of an eye. The sun beats down on smoking sand. Bodies, debris, and shattered palm trees litter the beach. Marines advance toward a fortified Japanese bunker. Machine gun fire erupts. A Marine squad dives behind wreckage. The rifleman can't get a clear angle, but the shotgun man can. He rushes forward. 3 blasts. The defenders fall. The bunker is cleared in seconds. This wasn't just brute force. This was physics, engineering, and bravery combined in one terrifying moment. The island is black. Black sand. Black smoke. Black volcanic ash raining like snow. Marines crawl forward, inch by inch, fighting for every crater and every mound of shattered rock. Inside the labyrinth beneath them, 11 miles of tunnels, chambers, and ambush positions. Japanese defenders wait like ghosts. This is not a battlefield. It is a trap. In Iwo Jima's tunnels, rifles became nearly useless. You couldn't aim. You couldn't see. You could only react. And reaction meant survival. In this suffocating darkness, only one weapon mattered. The trench shotgun. The Marines move slowly, flashlights trembling in their hands. The tunnels twist unpredictably. Left, right, down, abruptly ending in dead silence. Suddenly, a flash of movement. A Japanese defender charges with a fixed bayonet, screaming through the dust. There's no room to raise a rifle. But there is space for one devastating blast. Boom! The entire tunnel shakes. The enemy falls instantly. The Marines push forward. 20 feet later, another ambush. Another close-range fight. Another life-or-death decision resolved by a single pull of a trigger no longer than a breath. In the Pacific, the shotgun wasn't just a weapon. It was a lifeline. Japanese manuals and post-war interviews revealed a grim truth. They feared 3 American weapons more than all others. Flamethrowers, Thompson submachine guns, shotguns. The reason was simple. No armor, no cover, no reaction time. A single blast at close range ended everything instantly. In bunkers, trenches, and tunnels, places Japan believed it held the advantage. The shotgun flipped the battlefield. While Iwo Jima was hell, Okinawa was something worse. A battlefield where the environment itself felt cursed. Rain falls relentlessly. Mud swallows boots to the ankles. Japanese ambushes erupt daily from holes invisible to the eye. A Marine platoon moves along a soaked ridge. Visibility nearly zero. A sudden burst of fire cuts through the storm. Enemy soldiers pouring out from spider holes carved beneath the mud. Rifle fire scatters into the rain. But one Marine steps forward, calm despite the chaos. He carries the Winchester shotgun. 4 blasts. 4 defenders collapse. The attack ends as quickly as it began. The platoon breathes again. By Okinawa, the reputation of the American shotgun was no longer just feared. It was legendary. Even Japanese commanders noted it in their reports. The enemy's short-barrel gun causes heavy losses at close quarters. This wasn't a high-tech wonder weapon. It wasn't new. It wasn't glamorous. But in the hands of a U.S. Marine, it became something unmatched in the chaos of close combat. 1945 brought a ceasefire. But the shotgun's story wasn't ending. It was evolving. From Korea's frozen mountains to Vietnam's jungles. From urban warfare to counterinsurgency operations. The shotgun would remain one of America's most effective and feared weapons. Because in every war after WWII, one truth stays constant. When the fight closes to 10 meters or less. When there's no time to aim. No visibility. No space. The shotgun wins. Every single time. The Pacific War was nearing its final brutal stages. By mid-1945, Okinawa and Iwo Jima had shown the world a stark truth. The most subtle, often overlooked inventions could determine life and death. The American shotgun, along with other underappreciated innovations, had transformed close-quarters combat, convoy defense, and even the psychology of both attacker and defender. But the true turning point was not just in individual battles. It was in the cumulative effect of these inventions across theaters, creating momentum that Axis forces could not recover from. Across thousands of miles of ocean, American forces executed one of the most complex amphibious campaigns in history. From Guadalcanal to Peleliu, from Tarawa to Saipan, Marines and soldiers faced challenges previously unimagined. Logistics were stretched to their limits. Enemy positions were well camouflaged and fortified. Night operations, monsoons, volcanic ash, and coral reefs conspired to kill or delay troops. Yet every engagement demonstrated the growing effectiveness of hidden technological advantages. Amphibious vehicles that could cross reefs and deliver tanks safely to the beach. Radios and field telephones that kept units coordinated even in the chaos of landing under fire. Portable radar and sonar equipment that detected enemy movements before ambushes could form. Shotguns and flamethrowers for close-quarter dominance in tunnels and bunkers. The enemy, meanwhile, was reacting too slowly. German and Japanese reports from late 1944 and early 1945 repeatedly describe confusion, frustration, and fear as American forces countered previously secure defenses with surprising precision. At the same time, across the Atlantic, American inventions were equally decisive. U-boat attacks had cost the Allies hundreds of ships in 1940–42, but by 1943, with improved sonar, depth charges, and radio detection systems, convoys began reaching Europe with drastically reduced losses. Allied commanders recognized that the quiet inventions were reshaping the very nature of naval warfare. The pivotal moment came during Convoy HX-233 in May 1943. A wolf pack of U-boats attacked a transatlantic convoy. Escorts equipped with the latest American sonar systems detected the submarines at unprecedented range. Depth charges were delivered with pinpoint accuracy. Of the dozen U-boats that attacked, 7 were destroyed or forced to retreat. The battle marked a turning point in the Battle of the Atlantic, demonstrating the effectiveness of technological innovation coupled with tactical adaptation. These successes weren't simply about machines, they were about trust in the tools and the psychological confidence that allowed commanders to act decisively under pressure. Simultaneously, the production of synthetic rubber in the United States ensured that vehicles, aircraft, and mechanized divisions could continue moving. By 1944, American tanks, trucks, and jeeps outnumbered their Axis counterparts. Convoys could transport fuel, ammunition, and troops without fear of supply collapse. Without these invisible innovations, small circuits, synthetic materials, and clever mechanical solutions, the U.S. military might have struggled to maintain the operational tempo required to win simultaneous campaigns in Europe and the Pacific. Instead, the inventions created force multipliers, small items that amplified manpower and firepower in ways that were cumulative, unstoppable, and often invisible to the enemy. By August 1945, the war in the Pacific reached its violent conclusion. Iwo Jima, Okinawa, and other island campaigns had demonstrated the lethal effectiveness of close-quarter weaponry, amphibious technology, and battlefield electronics. The Atlantic, meanwhile, had been tamed by sonar and detection innovations that ensured supply lines remained intact. Every innovation, once obscure or forgotten, had converged into a single operational advantage. The Allies now had control of both ocean and air, the ability to supply forces across continents, and the confidence to press attacks under conditions that had previously been considered impossible. The turning point was not a single battle. It was a symphony of inventions, a chorus of ingenuity, and the relentless application of knowledge and industry. The war changed not just because of bravery, but because of intelligence applied to necessity. And as American forces advanced across islands and continents, the cumulative effect of these forgotten inventions became impossible to ignore, even to the enemy. The war had ended, but its consequences were measured not just in the surrender of Axis powers, but in the silent, pervasive influence of innovations few remembered. Across oceans, continents, and battlefields, the inventions that had quietly shaped victory left a tangible mark on both strategy and human experience. In the Pacific, islands once considered impregnable had fallen. Iwo Jima, Tarawa, and Okinawa revealed the effectiveness of American amphibious and close-quarter innovations. Japanese reports repeatedly noted how the U.S. Marines, equipped with shotguns, flamethrowers, and portable communications, seemed almost omnipresent in tunnels and bunkers. A single wave of Marines, advancing with coordinated fire and rapid communication, could neutralize defenses that previously required overwhelming numbers to breach. Beyond the battlefield, these inventions influenced planning and doctrine. The lessons of close-quarters combat and tunnel warfare informed U.S. military training for decades. Engineers began designing vehicles and landing craft with greater flexibility, anticipating not only conventional combat, but also irregular and jungle warfare. Equipment tested in the Pacific would evolve into the vehicles, radios, and tactical weapons used in Korea and later conflicts. In the Atlantic, technological advantages were equally decisive. By late 1943, the Allies had achieved near-complete control of the sea lanes. Sonar-equipped escorts, radio detection systems, and improved depth-charge mechanisms had turned the tide against U-boat wolfpacks. Convoy losses fell dramatically. What had once been a nearly weekly disaster became increasingly rare. Historians now recognize battles like Convoy HX-233 and SC-130 as early demonstrations of the power of American technological adaptation. Naval officers reported a profound psychological shift among crews. Where fear and uncertainty once dominated, confidence now guided decisions. Sonar operators no longer awaited attacks, they anticipated them. Captains maneuvered with assurance. Convoys moved in rhythm. The human dimension of war, once crippled by unpredictability, now thrived under the support of innovations that were largely invisible to the untrained eye. The broader strategic consequence of these inventions was striking. They allowed the United States to project power simultaneously in two oceans, a feat unimaginable before 1941. Supplies reached Europe and the Pacific with reliability, forces moved with coordination, and small units gained lethality disproportionate to their numbers. Meanwhile, the Axis powers faced a cumulative shock. Germany's U-boat campaign, once a critical lifeline for cutting Allied supplies, was rendered increasingly ineffective. Japan's defensive doctrine, built on entrenched positions and night ambushes, was repeatedly undone by innovations the Allies had quietly perfected. Enemy commanders, in post-war interrogations, noted the unseen hand that seemed to guide American operations. Technology, industry, and strategy fused in a way that was both overwhelming and subtle. Some statistics underline the tangible effect of these inventions. By the end of 1944, Allied convoy losses in the Atlantic had fallen from over 1,000 ships sunk per year in 1942 to fewer than 200, thanks largely to sonar and radar improvements. The production of synthetic rubber had reached over 800,000 tons by 1945, ensuring vehicles and aircraft remained operational. In the Pacific, Marine after-action reports repeatedly cited the effectiveness of the shotgun and specialized landing craft in securing objectives under extreme conditions. These numbers, while technical, illustrate a profound truth. The inventions that seem small or forgotten were in fact foundational to Allied victory. While the immediate consequences of the war were visible in surrender ceremonies, rubble-strewn cities, and exhausted soldiers, the medium-term effects of America's lesser-known inventions were subtler, yet just as transformative. These innovations reshaped doctrine, influenced post-war planning, and left a legacy that would echo through decades of military strategy. The battlefield lessons of World War II forced the U.S. military to rethink how wars were fought. The Pacific campaigns, where shotguns, flamethrowers, and portable radios had proven decisive, became case studies in small unit tactics. Marines and soldiers learned that mobility, communication, and technological support could multiply effectiveness beyond numerical strength. These lessons informed the development of post-war manuals, training programs, and even the creation of specialized units. Amphibious doctrine expanded, incorporating lessons from reef crossings, landing craft designs, and pre-landing coordination methods. Infantry small unit tactics evolved to emphasize flexibility, rapid adaptation, and the integration of technological tools like radios, night optics, and portable detection devices. Naval strategy increasingly relied on technology to maintain sea control, recognizing that sonar, radar, and communications could neutralize threats far before they reached striking distance. Many inventions developed under wartime pressure became the foundation for post-war military and civilian technology. Radar and sonar improvements evolved into early air traffic control systems, weather monitoring, and naval navigation tools. Synthetic materials developed for tires, seals, and fuel lines found applications in aerospace, automotive, and chemical industries. Field communications innovations, such as walkie-talkies, influenced civilian emergency services, broadcast technology, and early mobile communication devices. In effect, America's wartime laboratories had created a bridge between combat necessity and peacetime innovation, a bridge that would accelerate technological progress for decades. The Axis powers, confronted with America's rapid innovation, attempted to adapt, but often too late or insufficiently. German U-boat tactics shifted after sonar-equipped escorts became standard, but the sheer scale of Allied production and the technological leap made recovery impossible. Japanese defensive doctrines, built on fortified bunkers and night ambushes, were repeatedly countered by portable radios, radar, and the tactical deployment of weapons like the shotgun and flamethrower. These failures had a psychological impact. Axis troops and commanders increasingly viewed the Allies as omnipresent and unpredictable, eroding morale and accelerating surrender in some regions. The forgotten inventions had implications beyond individual battles. They helped establish the United States as a technological superpower. By merging industrial capacity with scientific innovation, the US set a model for future conflicts. Wars could no longer rely solely on manpower or courage. Control over technology, logistics, and information had become a decisive factor. Military historians now recognize that these innovations, though overshadowed by iconic weapons and battles, were force multipliers. They increased survival rates, enhanced operational efficiency, and allowed smaller forces to achieve objectives against well-entrenched enemies. Without them, campaigns like Guadalcanal, Tarawa, Iwo Jima, and even Atlantic Conv operations might have cost far more lives and prolonged the war significantly. War in its rawest form is chaos. It is fire, fear, and unrelenting uncertainty. Yet within that chaos, human ingenuity finds a way to create order, to impose solutions where none seem possible. The story of America's forgotten inventions in World War II is a testament to this quiet, relentless force. These inventions, small, overlooked, sometimes dismissed, did more than fill gaps in strategy or technology. They reshaped the human experience of combat, granting confidence where there had been fear, precision where there had been guesswork, and survival where there had been despair. From the sonar operators scanning the Atlantic for silent submarines to the Marines advancing through Iwo Jima's tunnels with a shotgun in hand, each device mattered because it empowered people to act decisively in the most extreme conditions. Their impact was cumulative. One innovation alone might have seemed minor, but combined, amphibious vehicles, radios, radar, synthetic rubber, the proximity fuse, and even simple tools like the trench shotgun, they transformed the nature of warfare. They allowed the United States to project power across oceans, to sustain complex campaigns, and to overcome enemies who had once seemed invincible. They changed not only what could be done, but how soldiers thought, moved, and fought. History often remembers the dramatic, the D-Day landings, the atomic bomb, the iconic tanks and planes. Yet the story of these quieter innovations reminds us that victory is built as much on ingenuity as it is on courage. It is a lesson in the power of preparation, experimentation, and the determination to solve problems no one else has solved. And beyond the battlefield, their legacy endures. They shaped post-war doctrine, influenced civilian technology, and created a model of innovation that persists in modern military strategy. They are reminders that progress often comes in forms too small to make headlines, yet too vital to ignore. In the end, the forgotten American inventions of World War II teach us that wars are won not just by the might of armies, but by the creativity of minds, the courage of innovators, and the quiet, invisible forces that tilt the balance of history. The machines, the devices, the synthetic materials, and the clever tools, once overlooked, became the invisible backbone of victory. And in that truth lies the lasting lesson of innovation under pressure.